right, so our learning target today is I can write and use an equation in y equals a times b to the x given 2 points. When I'm given 2 data points, how would you write the equation? We did this a lot in linear y equals mx plus b, where you have 2 data points. You first start with finding the slope, and then we find the y-intercept from there. We used to call it orange poster to pink poster in my class. So kind of the same concept of how do we write an equation when we're given 2 data points. So the first thing we're going to do is we're going to identify the a, and the a value is really the starting value. A little bit confusing when we compare arithmetic geometric sequences because we're so used to the b being the beginning in y equals mx plus b, and then it switches gears, unfortunately, in this exponential form. We'll do is plug in our xy coordinate, just like we've done in y equals mx plus b, so same thing. And we cannot use 0y. That's the only problem. We're going to have an issue when we use 0 for x because of the power on that. As we've talked about over the course of the last couple weeks, that when you have anything to the 0 power, it becomes 1. So there is a dilemma there. So you cannot use x as 0. That's the only thing to point out there. Then we will solve for b. That's really going to become our growth rate. Now remember, we can either grow or we can decay. Grow means it's a value, the base b is greater than 1. Or we decay where the base is a fraction between 0 and 1. Okay, so in the table here, we're going to do that. We're going to find we have 2 data points. We're going to find the a, the b, and the coordinate. All right, so the a is the starting value. Pretty easy to see here. It starts at 0, 1, so where the x is paired up as a 0. So our a value is 1. If we look at our growth factor, we're looking to see what are we going by here. And if we look at our table, we see that the growth factor is multiplication by 3. So our b value is multiplication by 3 all the way down. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. It has to work all the way down. The growth or the rule is multiplication by 3. Now I need 1 data point, 1 and only 1 data point to substitute into this to be able to check it. So I can really use any of them. I'm going to use 1, 3. You cannot use the 0 coordinate though because the power there. So I'm just going to use 1, 3, and I could check to make sure that that makes sense. So we're going to go ahead and plug in 1 in for x, a 3 in for y. Okay. So our equation then is y equals a is the beginning amount. The growth rate is multiplied by 3 to the x power. Now to check to make sure that works, we're going to plug in this coordinate here, x1, y3, and make sure that that makes sense. So we're going to plug a 3 in the y spot. We're going to plug a 1 in the x spot and make sure that that's true. So we're just looking for a check down here, checking this coordinate right here. So we have 3 equals 1 times 3 is 3. Yep, we got it. So this is just our check down here to make sure that this equation is correct. Our equation is y equals 1 times 3 to the x power. Okay, so this is called exponential growth. Moving on now to the next example. In the next example here, our beginning amount is 32. Our growth is kind of unknown there. Our growth is unknown. So in this particular case, I'm not sure what the growth is. So I'm going to say, I don't really know what the growth is. What do we do now? Well, we can take one of our data points, and I can't use the 0 data point. So I'm going to use 2, 5, 12. So I'm going to approach this middle problem a little different than the first one because I do not know the growth this time, where over here it's pretty obvious to me that the growth was 3. So our beginning amount, A, is 32. Our growth is unknown. We don't really know what we're growing by, so I'm going to use that as a B. And our X is unknown. However, I can take this data point XY and I can find it. So as I start to solve them, I'm going to put a 2 in for X and a Y in, or 5, 12 in for Y. So I put a 5, 12 in here. I put a 2 in for X. Substitution, solving, hand method. My job is to solve for the variable b squared. Get the b totally alone. So as I start to solve that, I'm going to divide by 32, copy, paste. So I have 5, 12, divide by 32 on the left-hand side. gives us 16. So we have 16 equals, whoops, b squared. I crossed off the wrong thing there. Sorry about that. Our job is to get the variable b totally alone. Right now it has a power of 2, so to get rid of the power of 2, we're going to take the square root, copy, paste. So we get the b, or the base is 4, which really means we're 4 timesing. The growth is 4 times, or quadrupling each and every time. So my final equation, going back to the beginning, is y equals the a value, the beginning value is 32. The growth is we're 4 timesing to the x power. So our equation becomes y equals 32 times 4 to the x power. That's our goal, is to write the equation. If I'm going too fast, go ahead and pause that video. Otherwise, we're going to keep on moving. So our next problem over here then. Our starting amount is the thing that's at the beginning at 0 is 18. You can see that there isn't a clear growth happening here. That's not obvious to us. So the growth is kind of unknown. We're going to solve for that and find that. I can use one data point to get me it. So we're going to go 3, 60.75, $60.75. So we have 3, $60.75. So our y value is going to be $60.75. Our a value is 18. Our growth is unknown, and it's to the power of 3. Solving for the b cubed. Now, this will be the first time you've seen this situation. We're solving for the variable b. It does have this cubed, or power of 3, attached to it. So first, we're going to undo the multiplication of 18 by division, copy, paste. So we have 60.75 divided by 18 gives us 3.375 equals b cubed. Our job is to get the variable b alone. Again, first time you've ever seen this. How do you get rid of a power of 3? You do something called take the cubic root. So it's like a square root, except it's not we don't have a power of 2. We don't have a square right now, so we can't take a square root. We have a power of 3 called a cube. So to undo that, we take something called a cube root. So you're going to take the same process, but you're going to put a tiny little 3 here, which means I'm taking the cube root. We're going to copy paste the cube root. So we're really asking what number when we multiply by itself 3 times gives us 3.375. So there is a button on your calculator. It's the y to the x button that you can use to find this, or you can use estimation. Bummer, I don't have that calculator pulled up right now on the screen. So there is a calculator button that has this going on. I believe there's an X out here and a Y on the inside. Frustrating. I don't know how to show that to you right now through this video without having it in class. So basically, you can ask me about that when we get back into class, where I can actually show it to you on a real calculator. I apologize for that. So the other option is to guess and check it, which is really hard to do. I understand that. What number when you multiply it by itself 3 times gives us 3.375? So these would cancel, giving us the b value, and the answer is 1.5. Again, I can show that to you in class when I'm back in class on how to find the cubic root. Again, the answer is 1.5. So go ahead and pick up that calculator and let's just double check that that's correct. So if you put 1.5 in your calculator, and you put it to the third power, 1.5 to the third power, or you can multiply 3 times, 1.5 times 1.5 times 1.5, you should end up with 3.375. So that just confirms that that is the cube root. Again, I can show you how to do that in your calculator when we get back in class. Sorry about that little gap in our video right now. Okay, moving on, guys. So going back to our job is to write this equation. Our final answer is to rewrite the equation. So we know the a value from the very beginning. It was an 18, so we're going to put that in the a spot. And we just found that the growth factor is 1.5. It's really like saying 50% growth. So we have y equals 18 multiplied by 1.5 to the x power. Okay, so that's how we do it when we're given a table. You're given a table, how do you write the equation? Given a table, how do I write the equation? Given the table, how do I write the equation? So what do we do now? How do we write an equation when we're given a graph? So kind of the same process. We're going to pull the points from the graph. The a value is the point where it crosses the y-axis, so it's going to be a 10. where it's paired to 0. We don't know the growth. It's not a straight line, so it's really kind of hard to find. And we know that the data point we're going to use is the data point of 112. So we end up with this scenario. So we have our y value is 12. And we know that the a value is 10. We don't know our growth, and the x value is 1. Solving. So we're going to solve using the hand method for b. Our job is to get rid of that problem, so we're going to divide by 10, copy, paste. So we end up with 1.2 equals the b value. So the b, or the growth, is 1.2. So our goal in this entire process is to be able to rewrite the equation. Now, if I'm going too fast, go ahead and pause the video. If you have a sub today, very politely, respectfully ask the sub to pause the video. So rewriting the equation, we have y equals, the a value is, that's so frustrating when that happens. The a value is 10. The growth is 1.2 to the x power, recognizing that this is really talking 20% growth. Because remember, you get 100% of the money back, plus a 20% bonus of interest in this particular case. So the entire answer that we're looking for here is right here. So our equation is y equals 10 multiplied by 1.2 to the x power. So we were given a graph, and we were asked to write an equation from the graph. All right, we're going to do that again over here. Again, if I'm going too fast, go ahead and pause that video. So we're given a graph, and we're asked to write an equation for the graph. So as we start to solve them, our starting amount is 8. We don't know the b value. And the data point I'm going to use is 1, 4. So we're going to use 1, 4 there. Okay. So solving, then, we go y equals, whoops, we do know the y, my fault. Hang in there, guys. So we know the y. Thanks for dealing with me today. The y value is 4, struggling. The beginning amount is 8. The growth factor is unknown, and it's not a straight line. It's nonlinear, so it's a little hard to decide. The x value is 1. Our job is to solve for the variable b. We're going to solve for the b. So we're first going to get rid of the 8. So we're going to divide by 8, copy, paste. So our growth factor is 1/2 then, because that's the value that gives us our b alone. You can see that it is a decay happening. It's approaching 0, so it makes sense that it is a fraction. The b value is 1/2. We're eating half the candy bar every day. And remember, our ultimate goal was to write the equation y equals a times b to the x. So we'd have y equals, the beginning amount is 8. We're 1/2ing each time, eating half the candy bar each and every day to the x power. So our equation then is y equals 8 multiplied by 1/2 to the x power for however many days it takes to eat the rest of the candy bar. Again, our goal was to take the graph and be able to write an equation for that learning target. All right, guys, so your homework for tonight is to be able to take tables and write equations, graphs and write equations. You need to work through all the way through page 32. So basically, your job is to finish the packet, finish up the packet. All the way through page 32. That is due tomorrow through page 32. Have a fabulous night, 8th grade.